So in the first step, let's launch the instance and explore the environment. So I'm going to click on Deploy Server, which is the way to launch the compute instance. Choose Cloud GPU. And depending on your budget, choose the GPU instance based on the GPU configuration. So for this demo, I'm choosing one of the high-end GPUs, the NVIDIA Llama2 and the location of your choice, depending on where you are. And also make sure the region that you're selecting has support for the Llama2 GPU. So once you do this, the next step is to select the operating system. We are going to choose the Vultr GPU Stack, which comes pre-configured with the entire AI ML stack, which makes it easy for us. And for this demo, I'm going to choose the entire GPU, but you can also choose fractional GPU depending on your budget and the foundation model that you plan to run. And once you select the GPU configuration, since it's a demo server, I don't want to incur additional cost by enabling auto backup. So I'm going to disable auto backups and give this a name, Gen AI Demo. So once you select all of this, make sure you have the configuration. So Cloud GPU, NVIDIA Llama2, the region of your choice, the GPU stack, the GPU configuration, and the cost that's involved. And finally, give it a name and click on Deploy Now. This is going to take a couple of minutes. You should see this become green and the status changing to running. So let's give it a minute or two and come back to this demo. All right, so now the status has become green and it shows running. So let's click on the server and you can see the entire configuration here. And there is also a remark that actually tells you that the server is still finishing the install. So to make sure it's ready, click on the View Console link and this opens the console. Now, you should actually see this message, reached target cloud init. Now, that's an indication that the server has been completely initialized and we are good to go with the rest of the steps. So it's time for us to get the IP address and then switch to the terminal. So the username is root and this is the IP address. And let's get the password from the console. All right, so we are now within the instance that we just launched. So it's time for us to explore what's inside this GPU instance. So the first command I'm going to run is NVIDIA SMI. So this is the Systems Management Interface command, which actually confirms the GPU presence. And you can see there is a Llama2 GPU associated and it has the entire 80 GB available to us. Currently, there are no models running, no processes running, so we have the entire 80 GB available to us. So this confirms that we have the driver installed. Now, the next step is to check out Docker. So I'm going to run Docker version, and this will show us we are running the Docker Engine Community Edition, and this is running both the client and server. So that means Docker is fully installed. You can now check whether the NVIDIA Container Toolkit is installed. And this command called NVIDIA CTK confirms the install of the CLI. Now you can use this to configure the container runtime of your choice. But the Vultr GPU Stack already comes with a pre-configured Docker runtime with the NVIDIA container runtime. So to confirm that, let's run Docker info. So within Docker info, you'll see a lot of details, but what we are most interested in is the runtime key. So it shows us that the NVIDIA runtime is installed, and we can now target this by passing appropriate parameters to Docker engine on the Docker container that we are going to run. But the Docker engine is already configured with NVIDIA as one of the available runtimes. So this is perfect. This confirms that we have the NVIDIA drivers installed, the NVIDIA container toolkit configured and installed, and of course we have Docker up and running. So to make sure we have the CUDA, that's the runtime needed for libraries like PyTorch and TensorFlow, let's launch Python. So we see that Python 3.8 is already installed. So let's get into the Python environment, and I'm going to import PyTorch by using import torch, and then run a couple of methods. So when you run torch.cuda.device count, it shows 1. You can even access the name of the device. So this is the Llama100 multi-instance GPU available on this machine. Perfect. So we not only have the GPU, but we also have the appropriate drivers and the CUDA runtime installed within the instance. Finally, let's make sure we have the Docker engine fully configured by running this command. So by passing the runtime is equal to NVIDIA GPUs all, we'll be able to access the underlying GPUs through containers. Now this step verifies and confirms that Docker containers are indeed able to access the underlying GPU. So what I'm doing here is I'm launching the default Ubuntu image, and I'm running NVIDIA SMI inside that. And because I'm passing runtime is equal to NVIDIA and GPUs all, this should quickly download the Ubuntu image and then run the NVIDIA SMI within the container. And within that, we are able to see exactly the same output as the host machine. That means we are able to access the containers, the GPUs from the containers. So that's the first step. What we have seen so far is the software configuration of the Vultr GPU Stack. We have confirmed that it is running NVIDIA drivers, NVIDIA CUDA, Docker engine, NVIDIA container toolkit, and we are able to launch containers and access the GPU from the containers. So in the next part of this demo, we'll run one of the popular foundation models from Meta called Llama2. So let's go ahead and explore that. Okay, so in the previous step, we have seen that the Vultr GPU Stack instance is completely configured and ready to run the foundation model. So it's time for us to understand how we can run Llama2 for inference on this instance. So the first step is to get access to the Llama2 model. You can do that by visiting ai.meta.com/llama. You can do a Google search to get to this page. And this talks about various flavors of Llama2. It has a 7 billion parameter model, 13 billion parameter, and 70 billion. Now, these parameters translate to the data set on which the foundation model has been trained. The larger the data set, the larger the parameter size. So we can comfortably run the 7 billion parameter on the Vultr GPU Stack, even if you are not running the entire Llama100. Even on a fractional GPU, you should be able to run the 7 billion parameter Llama2. So in order to run this, you have to apply for access. So click on download the model, and here you'll actually see a form which will prompt you for some details. And once you enter, you can choose Llama2, Llama2 Chat, and Code Llama. So Code Llama is another foundation model that has been trained on code repositories, and it is typically meant for generating code. So if you want, you can select both. It's a good idea to actually have access to both. So populate your details and then click on this, submit the form. And in just a few minutes, you'll be able to receive an email to the address that you gave during the access form, during the access process. And it looks something like this. So the mail is from Meta AI, and you can see that we got access to both the Llama2 and Code Llama models. So there are instructions on how to go ahead and use the Llama2 model. You have two choices. One is to visit the GitHub repo and follow the instructions there. You can clone this repo and then run a file called download.sh, and this is going to prompt for a URL that's available within the mail. And once you run download.sh and provide this link, and by the way, this expires within 24 hours, so you want to make sure you downloaded the weights within 24 hours of getting this email. Then you have the complete model available within this repo, and after that you can follow the instructions available on this README page. The other mechanism which we'll be using throughout this series is to go via Hugging Face. So Hugging Face is an open source repository of various data sets and models. It's almost like the GitHub for foundation models and data sets. So Meta has also published the Llama2 models on Hugging Face, but you can access them even on Hugging Face only after you got the approval from Meta. So now that we have this approval, we can go to Hugging Face and search for Llama2. So you actually see that we have the Llama2 models available here. If you go to Meta Llama on Hugging Face, you see a variety of models. Basically, there are two types. One is the set of models available with PyTorch model weights. Then Hugging Face version of the model, a flavor where Hugging Face has converted the PyTorch models into a format called safe tensors. Both are exactly the same, but the Hugging Face flavor of Llama has been optimized for downloads and loading the model into multiple shards. So this is more efficient if you are using the Hugging Face libraries and the Hugging Face way of running the inference code. And since we are actually doing that, we'll be downloading the Hugging Face flavor of Llama2. So that's the first step. Then you got to, of course, sign up with Hugging Face and then go to Settings, go to Access Tokens, and create an access token. Now, this access token is required to download and upload models, datasets, and other artifacts associated with your project and your account. Now, you can create an access token just to pull, which is read, or push, which is write. Now, I have already gone ahead and created this token, but if you don't have, you can create one within the Hugging Face. You can go to your profile settings and then access tokens and create a new token. So once you have the approval from Meta and an account with Hugging Face and a token, we are ready to get started with our first foundation model application. So to run the model, I'm introducing you to a format, or rather a Docker image, based on what is called as the text generation inference. So text generation inference is a standard library and a framework from Hugging Face. So it is used in production at Hugging Face, and it's easy to run through Docker. So what we are going to do is we will now run a Docker container that actually has the text generation interface, or TGI for short. We're going to run this on the Vultr GPU Stack instance that we just launched in the previous step. So you can access this at github.com, Hugging Face text generation interface, and there are steps to run models that are available on Hugging Face. Now, this is optimized for a set of models, and luckily Llama2 is one of those models. So what we'll do is we will run a container that exposes an endpoint for us to generate the text either through curl or using the Python library. We'll explore both. So let's switch to the instance and get started with the text generation inference container. So I'm going to first initialize some environment variables. So we are going to initialize this variable called model, and we are running the Llama2 7 billion chat Hugging Face flavor of the model. And then we need to give a directory where we are going to keep the data. So it's a good idea to create the directory beforehand and then point this environment variable called volume to the data directory. Now this is where the container will store the downloaded artifacts like the model weights. And then you also need to populate the Hugging Face token, because we are accessing a model that's gated in the sense that it is not available unless approved by the model provider. In our case, it is Meta. So what we'll do is we'll go ahead and populate this token. Let's go ahead and launch the Docker container and pass these parameters that we have initialized as environment variables. So we are running the Docker command here with run -d. -d is to run it as a background process. Name of this container is h of TGI. Runtime is NVIDIA, and we want to consume all the GPUs. We are passing the environment variable, initializing the Hugging Face hub token with the token that we have populated earlier. This container is exposed on port 8080, and the volume is mapped to the data directory that we created earlier in the previous step. So this is going to basically run the container and then initialize the text generation inference container by downloading the model. Be patient. This is going to take a few minutes depending on where you are launching this. It might take anywhere from 2 minutes to 7 to 10 minutes. So be patient, and we'll monitor this container after it moves into the running mode. So the first step is to download, or rather the pull process, the Docker pull image, and then run the command inside the Docker container, which is going to download the Meta Llama2 7 billion parameter model. So that's the second step. So we are currently seeing the first step where the container is now getting pulled and moving into the running mode. So as soon as we are back to the command prompt, we can access the logs to monitor the status of this container. And you should wait for a prompt that says the web server is up and running, and that's an indication that the TGI container is now available for us to run the client to generate text or to interact with the model. Okay, so this is still in the first phase of downloading and extracting the image. This should be done. All right. So now the Docker container is launched and we can verify that with Docker PS. So you can see that the container is running. It's up for 5 seconds. Now our container is called HFTGI. So what we can do is we can actually look at logs by passing the name of the container. So this is going to show us that the model is now getting downloaded. So it is starting the download process. These are pretty large. Just to give you a sense of how large they are, let's switch back to Hugging Face and go back to the Llama 2 landing page, the model card where you can see. So the Meta Llama 7 billion parameter HF is actually going to, this is the one that we used. So if you go to files and versions, you can see that there are multiple shards of the model weights. And the first one is 9.95, close to 10 GB. The next one is another 10 GB. And the third shard is about 6 GB. So our model will have to download all of them. And looks like it has already downloaded. So this is pretty fast. So now it successfully downloaded the weights and it is waiting for the shard to become ready. This will take just a couple of minutes and we should be able to see the interface where it actually says the web server is ready, and then we can hit the endpoint, the API endpoint with curl, and then I'll show you how to launch a Jupyter Notebook and run the client interactively with a Python module or within the Jupyter Notebook. So let's give this a minute. Okay, so now the model is up and running. What is the indication that it's successfully launched? Well, you can see that the shard is now ready and the web server is also up and running. So when it says invalid hostname defaulting to 0.0.0.0, that means the web server is available. Now we can come back to the command prompt and run a very simple test. So if you actually see in the TGI GitHub repo, there is a curl command. So copy this, come back to the terminal and run this. And this should actually verify that the web server, which is acting as the interface to TGI, is available. And there we go. So now you can ask the model what is deep learning and it comes back and gives us the answer. This is perfect. So now we are able to run a foundation model on Vultr GPU Stack with just a single command. But that's not all. I want to show you how you can start integrating this with your applications. So what is that we need to access this outside of Vultr, where you may be running your applications either locally or in any other cloud environment or even within Vultr's cloud environment. So we need to install a Python module provided by Hugging Face, and it's called the text generation module. So pip install text generation gives us the access to the Python API or the Python SDK for the TGI that we just launched, the text generation inference. So with that in place, we can now go to our browser and access the Jupyter Lab. So Jupyter Lab is already installed in Vultr GPU Stack, and it's pretty straightforward for us to access that. So what we need to do is we have to construct a URL. So come back to the Vultr GPU Stack, grab the IP address, and then we are going to type the IP address of our GPU stack, followed by the port, which is 8888, and /lab. Now, this is going to show us the landing page of the Jupyter Lab. Now, at this point, we are expected to share the password or enter the password to access the Jupyter Lab environment running in the GPU stack. And where do we get that from? Well, it is straightforward. Because the Jupyter Lab is already installed, the token can be accessed from the Jupyter Lab logs. So var log Jupyter Lab lab.log. So this actually has all the logs, and within this, you'll be able to find the token responsible for authenticating the user. So now let's come back to the browser, paste the token that you grabbed from the logs, and log in to Jupyter Lab. Perfect. So here we are within the Jupyter Lab environment. Now let's launch a new notebook, and we can rename this to client. And we are going to use Python to basically run the SDK, or rather the module, access the TGI interface from the Jupyter Notebook interactively by consuming the text generation pip module. So the first step is to import the module. You may ignore the warnings that you may see, and then you have to set the URI. So the URI is the IP address of the instance, right? For example, in our case, it is ending with 140. That is what I'm using here. So and 8080 is the port on which our inference server is listening. So let's run this. And then we're going to initialize the TGI client based on the URI. And then we are going to send the prompt that says, what is the most important tourist attraction in Paris? So we will initialize this. So now the TGI client is initialized with this URI, and we are ready to invoke the LLM with this prompt. So let's run this. There we go. Now it comes back and says the Eiffel Tower is the most important tourist attraction. So this is pretty accurate, not bad for a 7 billion parameter, and it's been pretty responsive. So if you actually see, the response has been pretty quick. So that's the end of the second part of the demo, where we have run the container which is responsible for exposing the LLM and an endpoint for us to invoke. Before I wrap up, I want to show you one thing that we might need to know as we proceed with this series. We just saved our Jupyter Notebook with the name client. So where are those notebooks available? Well, you can access those notebooks by visiting the Jupyter directory, the Jupyter home directory in the instance, and within that there is notebooks, and this is where you have the client.python notebook file available. So if you want to manually copy it or move it to your block storage device, you can do that. So this is the location where all your notebooks are going to be stored. Okay, so I want to summarize what we have seen so far. We launched a Docker container that encapsulates the text generation inference and the model, and then we tested it with a curl command and then we installed the text generation Python module and launched the Jupyter Notebook, grabbed the token, passed it on, and then we are able to programmatically access the text generation inference endpoint and generate the response from the LLM. So in the next section, I'm going to walk you through the details of LLM, the fundamentals of large language models that you need to understand before we go about building applications that are powered by LLMs. So thanks for watching. Stay tuned. And if you haven't subscribed to my channel yet, this is the time to subscribe. I have a very interesting lineup in the next few weeks. So stay tuned as we go through this journey of exploring open source foundation models on Vultr GPU Stack. See you.